Hello students, in this video I am going to solve some important sums from the exercise of NCERT book. First, exercise 2.1, not all the sums, some of the important sums which I think you may feel some problem during solution. First question, which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. I am doing for one sum number 3. It is 3 under root t plus t under root 2. This implies p of t, t is the variable, is equal to 3t to the power half plus t root 2. What we see? We see that t to the power half, the power of t is not a whole number. Therefore, it is not a polynomial. Your answer is not a polynomial. Why not? Since power of t, index power or power of t is not a whole number. That is why this is not a polynomial. Then I am doing 1/4. Y plus 2 by y. That is p of y in terms of y is equal to y plus 2y to the power minus 1. Again, y to the power minus 1. This should not be negative. This power should not be negative. Your answer, not a polynomial. Since power of y is not a whole number. Why this is not a whole number? Because this is minus 1 and minus 1 is not a whole number, we know. Then number 5. X to the power 10 plus y cube plus t to the power 50 not, this is a polynomial but not a polynomial in one variable. You cannot say not a polynomial. You have to say not a polynomial in one variable. Not a polynomial in one variable. What are the variables? There are 3 variables, x, y and t. Since there are three variables, x, y and t. Next, for sum number 2, write the coefficients of x square in the following. I am doing third sum of 2, which is p of x is equal to pi by 2 x square plus x. So x square, leaving x square, what is there? Pi by 2. So what is the coefficient of x square? Therefore, coefficient of x square is pi by 2. For the fourth one, say p of x is equal to root 2x minus 1. There is no x square term, mean we can write this is equal to 0x square plus root 2x minus 1. So what is the coefficient of x square? Coefficient of x square is 0. Therefore, coefficient of x square is 0. Next, for the fourth one, in the fourth, write the degree of each of the polynomial. I am doing 4, 2. Say p of y is equal to 4 minus y square. What is the variable? Y. What is the index power of y? Maximum index power 2. Therefore, degree 2. Therefore, degree is equal to 2. Next, classify the following as the linear, quadratic and cubic polynomials in the worksheet. As I have given so many such questions, so I am not solving this one. This is actually very easy. This is not actually a problem, will not be a problem to the students. Next, from exercise 2.2. Exercise 2.2. From 3 I am doing. Verify whether the following are zeros of the polynomial indicated against them. So I am doing 3, 3 means third sum of question 3. P of x is equal to x square minus 1. And you are given x is equal to 1 minus 1. First, P of 1 is equal to 1 square minus 1. That is 1 minus 1. That is equal to 0. So what becomes 0? Therefore, x is equal to 1 is one of the zeros of the polynomial. Similarly, P of minus 1 is equal to minus 1 square minus 1. 1 minus 1 is equal to 0. Hence, x is equal to 1 comma minus 1 are zeros of the given polynomial. Of the given polynomial. Okay, why these are zeros? Because for these values of x, the polynomial becomes 0. That is why. Next, I am doing sum number 6 of 3. Sum number 6. P of x is equal to Lx plus m. You are given that x is equal to minus of m by L. So, P of minus of m by L. What you have done it here? in place of x you have written minus m by L. So in the expression where there is x, we will write minus m by L. So this is equal to L into x. Now put down the value of x, minus m by L plus m. LL cancelled. There is minus m plus m. That is equal to 0. Hence, x is equal to minus m by L is a 0 of the given polynomial. Next, sum number 4. Find the zeros of the polynomial in each of the following cases. Here I am doing sum number 6. What you are given? P of x is equal to ax, where a not equal to 0. Now the value of x which will make p of x is equal to 0. So here p of x is equal to 0 implies ax is equal to 0, implies x is equal to 0 by a. X is equal to 0 by a, that is equal to 0. So what is the 0 of the polynomial? Therefore x is equal to 0 is a 0 of the given polynomial. Given polynomial. Next, sum number 7 of 4. Sum number 7. P of x is equal to cx plus d, where c not equal to 0, c and d are real numbers. Again same, you need to put the value of x for which the polynomial will become 0. Thus, p of x is equal to 0 implies cx plus d is equal to 0 implies cx is equal to minus d implies x is equal to minus d by c. Therefore, x is equal to minus d by c is a 0 of the polynomial. Is a 0 of the polynomial. Next, exercise 2.3. Now in exercise 2.3, I will also do some of the important sums. Exercise 2.3. 1. Find the remainder when x cube plus 3x square plus 3x plus 1 is divided by, say, x plus pi. That is, there are two polynomials. Here, p of x is equal to the given polynomial, that is x cube plus 3x square plus 3x plus 1, and g of x is equal to x plus pi. You have to follow the method in what way I am doing the sum. This is the actual way how to do the sums. Here, g of x is equal to 0 implies x plus pi is equal to 0 implies x is equal to minus pi. Now, P of minus pi. So in this place substitute x by pi. So minus pi whole cube plus 3 minus pi square plus 3 into minus pi plus 1. So this is equal to minus pi cube plus 3 pi square minus 3 pi plus 1. So this will be the remainder. This will be the remainder. Next, sum number 2. Find the remainder when x cube minus ax square plus 6a minus a is divided by x minus a. Similarly, here p of x is equal to the given polynomial, that is x cube minus 6 minus ax square minus ax square, then plus 6x, then minus a. I think I have given this sum in the worksheet. G of x is equal to x minus a. Now similarly, first g of x is equal to 0 implies x minus a is equal to 0. You need to write g of x is equal to 0. For some of the students, I have seen the answer, you directly have written x minus a is equal to 0 implies. You cannot write that. Now x minus a is equal to 0 implies x is equal to a. Therefore, P of a is equal to a cube minus a into a square plus 6 into a minus a. So this is equal to a cube minus a cube plus 6a minus a. Minus a cube plus a cube cancels. 6a minus a, 5a. So what is the remainder? 5a. So this is the remainder. This is actually remainder r of x. It is the remainder. Next, sum number 3 of exercise 2.3. Sum number 3. Check whether 7 plus 3x is the factor of 3x cube plus 7x. Let here p of x is a given polynomial, that is 3x cube plus 7x, and g of x is equal to 7 plus 3x. As previous, what we were doing, g of x is equal to 0. So g of x is equal to 0 implies 7 plus 3x is equal to 0 implies x is equal to minus 7 by 3. Therefore, p of minus 7 by 3 is equal to 3 into minus 7 by 3 whole cube plus 7 into minus 7 by 3. So this is equal to 3 minus 3 into 7 into 7 into 7. 7 into 7, 49. 49 into 7, that is 343 I think. 7 9 is 63, 3 carry 6, 28, 34. That is 343. So 343 by 3 cube, 27. Plus minus minus 7 7 ja 49 by 3. 9 3 ja. So LCM 9 and 3 is 9. Now minus 343 minus. 3 3 ja 9, 3. 3 9 ja 27, 7 carry 2. 3 4 12, 13 14. 147. That is equal to, now same sign to be added, 7 3 10 0 carry 1. 4 4 8 8 1 9 0 no carry 3 1 4. So minus 490 by 9. If you have any doubt, you add it here. 343 147 7 3 10 0 carry 1. 4 4 8 1 9 no carry 3 1 4. So 490. This is, so this will be the remainder. It is the remainder. Is the remainder. Okay. Now what you get, as the remainder is not 0, as the remainder is not 0, therefore 7 plus 3x is not a factor of 3x cube plus 7x. Okay. Next, exercise 2.4. In exercise 2.4, determine which of the polynomials has x plus 1 is as a factor. So I am doing sum number 4. So 1 4. What you were given? P of x is equal to x cube minus x square minus bracket 2 plus root 2 x plus root 2, and g of x is equal to x plus 1. Now g of x is equal to 0 implies x plus 1 is equal to 0 implies x is equal to minus 1. Therefore p of minus 1 is equal to minus 1 cube minus of minus 1 square minus 2 plus root 2 into minus 1 plus root 2. Minus 1 cube means minus 1 minus 1 square means 1. So this is plus, plus minus minus, so minus 1 minus. Now minus into minus plus. So 2 plus root 2 plus root 2. That is equal to minus 1 minus 1 minus 2 plus 2 plus root 2 plus root 2 plus 2 root 2. This implies this cancels, so 2 root 2 not equal to 0. Okay, not equal to 0. Therefore x plus 1 is not a factor of given polynomial. You will check every calculation again. It may be that I have done wrong, okay, during the calculation. Okay. Now, sum number 2. Use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. Method of solution is the same. I am doing third of 2. P of x is equal to x cube minus 4x square plus x plus 6, and g of x is equal to x minus 3. Same way as you have done it. g of x is equal to 0 implies x minus 3 is equal to 0 implies x is equal to 3. Therefore, p of 3 is equal to 3 cube minus 4 into 3 square plus 3 plus 6. That is equal to 3 cube means 27 minus 3 3 is 9, 9 4 36 plus 3, okay, plus 6, that is 9. So what do you get? 27 plus 9, 36 minus 36, that is equal to 0. Therefore, g of x is a factor of p of x. So you get the answer. Now sum number 3, find the value of k if x is equal to 1 is a factor of p of x. Now I am doing here sum number 3 of 3. 3 of 3. Here you are given p of x is equal to kx square, kx square minus root 2x plus 1, and g of x is equal to x minus 1. Okay, now g of x is equal to 0 implies x minus 1 is equal to 0 implies x is equal to 1. Now you are said g of x is a factor, x minus 1 is a factor of this polynomial. So the value obtained from g of x will satisfy this equation, that is will make the polynomial 0. Therefore, p of 1 is equal to k into 1 square minus root 2 into 1 plus 1. This implies 0 is equal to 1 is the 0 of the polynomial, that is why p of 1 is equal to 0. K into 1 square, that is k minus root 2 plus 1. This implies k is equal to root 2 minus 1. This will be the value of k. Now I am doing 1 of sum number 4. 1 of sum number 4, this is 12x square minus 7x plus 1. Middle term factor 12 into 1 is equal to 12. Now we need to write two factors of 12. Whenever they are added or subtracted, you will get 7. Now 12 is equal to 4 into 3. 4 plus 3 is equal to 7. So this is equal to 12x square. Now 7 means 4 plus 3. So minus 7x, that is minus 4x minus 3x. So minus 7x plus 1. From the first two, take 4x common. So 4x common, 4 3 is 12. So 3x minus 1. Minus 1 common, 3x minus 1. Now students, here you see, if you see that these two terms are same, it means your sum is right. So this is equal to 3x minus 1 and 4x minus 1. So factors done. Now sum number 5, I am doing sum number 2 of 5. Sum number 2 is x cube minus 3x square minus 9x minus 5. Now for this sum you cannot do the middle term factor since the index power, that is, this is the cubic polynomial. Now 5 means 5 is equal to 1 into 5. 5 means minus 1 into minus 5. So either 1 or 5 or minus 1 or minus 5 will make the polynomial 0. Let us test. If this is p of x, then let us find out p of minus 1. So minus 1 cube, then 3 minus 1 square, minus 9 into minus 1 minus 5. So this is minus 1, this is 1 into 3 minus 3, then this is minus plus 9, then minus 5. So minus 9 plus 9, that is equal to 0. Therefore x plus 1, because value of x is minus 1, therefore x plus 1 is a factor of p of x. P of x. Now you have to divide p of x by x plus 1. So let us divide p of x by x plus 1. So let us divide p of x by x plus 1. We will get p of x is what? X cube minus 3x square minus 9x minus 5 by x plus 1. Now x plus 1, let us divide x cube, x, so x square. So you will get x cube plus x square. Change the sign, this cancels. Minus 3x square minus x square minus 4x square minus 9x minus 5. So minus 4x. Minus 4x square plus minus minus 4x. Now plus plus, this cancels. Minus 9x plus 4x minus 5x minus 5. Now minus 5. Minus 5x minus 5. Change the sign, this cancels. So R 0, remainder 0. So what you get, that is q of x quotient is equal to x square minus 4x minus 5. Again make a factor of this one, since power 2, this is the Middleton factor. This is equal to x square minus 5x plus x minus 5. This is equal to x common, x minus 5 plus 1 common, x minus 5. You will get x minus 5 into x plus 1. So what are all the factors? Therefore all the factors of p of x is equal to x plus 1 into x minus 5 into x plus 1. That is equal to x plus 1 into x plus 1 whole square into x minus 5, or you can write in this way. So up to exercise 2.4 I have done. In my next video I will give you the solution of the remaining exercise. At least I will try to give you the solution. Till now it is up to this for today. Okay.